Hello, my name is Davey, and in this first episode I will teach you how to select an LED and select a series resistor to go with it. It's quite theoretical maybe, but it's just so that you can get a little bit self-confident around these electronics. Self-confidence will result in better choices. So here we are on the computer, and I've selected this professional website called Newark. In Europe it would be Farnell. It's the same business, I think. But because most of you are from the US, I chose this website. DigiKey I think is the same RS Components. Well, the reason why I chose this professional website instead of Amazon or eBay is because the amount of useful information professional websites provide to engineers. We want to make a smart decision on which LED to choose for our booknook or for our diorama, so this website provides us with all this information. So since we want to do some lighting, we choose optoelectronics and then LED products. And well, there's another menu to choose from here, but we are mostly interested in standard single color LEDs under 75 milliamps or standard white LEDs under 75 milliamps. This is more about colored ones, this more about white ones. It's kind of, well, straightforward. So let's say we're interested in a white one. Now, the very good thing about a professional website is this filter section here, where we can filter out what we don't need, and it's really nice. Actually, there's two main types of LEDs. It's these ones, the SMDs, surface mounted devices. Most recent electronic projects will be done in these because they can be placed by a robot and soldered in an oven. Whereas the ones we will probably use for now are the true hole ones that require manual labor and soldering individual pins. But for us, for hobbyists, it's easier to work with this type. So if we check the filter, then we can already filter out what we want in the mounting section. So we want the true hole ones to filter. And then another filter we could choose is the color temperature of the LED. So cool white we would use for nighttime dioramas or spaceship science fiction-ish things, where the warm white ones are more for coziness. Regular white will be somewhere in between warm white and cold white, and actually it's easy to make a warm white from a white one. You just need to add some yellow paint, yellow translucent paint on top of the lens, and it will give a warmish hue to it. So if you want to buy, let's say, a couple of LEDs just to have them for next projects, it may be more interesting to take just regular white, which I will do for this demonstration. So, well, I've selected this one now. Another interesting thing is the luminous intensity, and here we can choose from a few options. The nice thing about this particular website, it gives the luminous intensity in candelas, and candela is it's a way of expressing how much light something gives. And one candela is about the same as one wax candle, as the amount of light that is emitted from one wax candle. So let's say that we want somewhere between, and this is also nice that we can select it here, we want something between the light of 4.5 candles and, let's say, 9 candles. And we submit this filter, and then if we type apply filters, we have now 11 filters selected, and this is what we get. all of these LEDs. So we narrowed our choice down to 14 products. And well, the next thing that I would do is to sort in price actually. Well, those are not in stock. And then we can have here, well, a 3mm LED. It's the size of the lens diameter. It's 3mm. We also have one in 5mm. Let's say that we are interested in this one, this 5mm LED. If we select it, then we go to the page of this. Well, apparently there's only 7 in stock, but so anyway, you need to choose a little bit what works best for you. So usually they already give some data here in the description. It's LED white through a hole, 5mm LED. And actually these two values for us are really important when we want to calculate a series resistance, a resistor for for a certain LED. So it says that it consumes about 20 milliamps or 0.02 amps, as we will use it in the formula, and 3.4 volts. Actually, we need, if we would order these ones, we really need to well, write it down or whatever. I will go a little bit more technical, maybe. There's always in professional websites a datasheet provided. This is for the engineers to really see if this particular device is completely fit for the thing that they're designing or building. So if we check the datasheet real quick, I know it's really technical and it's not all that interesting, but some things are quite noteworthy, let's say. So we're absolutely not interested in this really, but we are interested in the maximum ratings and the electrical characteristics and optical characteristics, sure. What is something that nobody actually usually talks about with LEDs, but is well, a little bit important? It's the reverse voltage. Reverse voltage means that when you connect the LED the wrong way, if this voltage you provide, let's say, is a 9 volts battery, you can actually damage the LED by connecting it the wrong way. So if this voltage is higher than 5, you might damage it. Something to note. We are interested in the forward voltage. It will be minimum 2.7, maximum 4, but for our calculations we use the typical value, and recommended operating current would be 20 milliamps. It's quite standard for LEDs, 20 milliamps. The thing about LEDs, and it's really nice, if we calculate our series resistance later, then we can actually reduce the amount of emitted light. We can essentially dim the LED by reducing this current. It's not really half. Let's say if we would provide the LED with 10 milliamps, that it would be half the amount of light, but it would be significantly less, and we can actually play with this. So if you make something and it's too bright, then no worries, you don't need to throw the LED in the bin and order a new one. You can actually pretty easily dim the amount of light that it gives. Another thing about graphs is there is usually such a, let me see, this one, a radiation diagram. So what we can make out from this is that it actually bundles the light between 0 and 10 degrees, which is pretty narrow. It's not necessarily a problem, because if it's too narrow, So this one actually shoots straight forward. But if it's too narrow, you can always use a nail file and file the top of the LED so that it diffuses much more, or you could put some piece of paper in front of it to make it more diffused, or some hot glue will even work. And that way you will kind of emit more light here to the sides, but with less intensity. So as is written here, and you would look straight into the lens of the LED, you would see the light of, what was it, of 9 candles burning. That's essentially what it is. If you would look from a 90-degree angle to the lens, you would almost see nothing. So now that we have selected our LED, we need to calculate our series resistor. From the datasheet of this LED, we remembered that it was 3.4 volts forward voltage and 20 milliamps of forward current. So actually what we need now is a calculator, and we will do the dreaded Ohm's law, actually a variation on Ohm's law. Ohm's law states that the resistance is the voltage divided by the current. In our case, we actually want to we actually want to strangle the current so that we do not blow up our LED. And how do we do it? We actually subtract the voltage that our LED needs. We subtract it from the voltage we provide, and then we divide it by the current that the LED needs. So, well, I will definitely put something on the screen for you. But what actually happens is you choose a voltage. Now, please don't use mains voltage. In theory, it's possible, but it would be extremely dangerous. So use a battery or a USB charger or whatever. So, well, let's assume that we use a USB charger or a power bank. In a later video, I will design with you something to keep a power bank alive, because if you choose a power bank, you might run into troubles that after, I don't know, 30 seconds or something, it will shut off by itself. So, but anyway, use the USB charger of a phone that's still lying around, maybe. So USB has a standard voltage of 5 volts. So we supply our circuit with 5 volts. And the calculation is pretty simple, though it looks like maybe you once saw it in physics class or whatever. It looks like something extremely difficult, engineering, blah blah blah, but it's absolutely not difficult. What you do is you take your 5 volts that you supply from USB charger, and you subtract the voltage that your LED needs. So in our case it was 3.4 volts, which gives you 1.6 volts left. And then you divide it by the current. So the current that our LED needs or wants to consume is 20 milliamps. So 20 milliamps is the same as 0.02 amps. So it's important in a formula to always use the main I don't know the word in English actually, well, to use amps, not milliamps or microamps or gigaamps or whatever. You always first put it into the main name, or it will have a name. So write it in the comments how it's called, like meters or liters or well, in this case amps. So 1.6 divided by 0.02 will give you 80 ohms. This is the resistor we actually need, 80 ohms. But, and there's a but, since everybody does some calculations and everybody figures out which resistor they want, and it will be all different, the people that make resistors, they kind of told like, well, you know what, we will make some standardized stuff and you can choose from this and only this. Which brings us to E12 series of resistors. There's E6, there's E24, there's E48. The more resistance values that you can buy, you can probably buy one of 80 ohms, but it will be more expensive than this E12 series. If you just type it in Google, it will automatically give it to you. Like if you type E12 resistor values, which is the cheapest, well, probably the most standard resistor series, you will get some values here. And what it actually is, it means that there's 12 values per decade, well, decade probably in English, which means that between 1 and 10 there's 12 values, these 12, but between 10 and 100 there's also these 12 values, so that would be 10, 12, 15, 18, 22, 27, till 82. So since we calculated that we need 80, 82 is pretty close. So if you would go for higher from 100 to 1000, which is also a decade, it would be 100, 120, 150, all the way till 820. And so it keeps going till somewhere in the mega ohms or the million ohms. But we are really happy with our 82 we found here. It's closer because of the fact that we go a little bit higher than what we calculated. The current through the LED will be a little bit lower, so we will not damage it. If we would take 68 ohms, it would be a little bit more bright, but it would not have the same lifetime as when we go a little bit under current. So 82, let's find our 82 ohm resistor. So on the same website we can go to passives, because resistors are passive components, as we call them, and the first one we find here is resistors, a fixed value. So we need a fixed value. There's also variable resistors, what called potentiometers, so it's a difficult word. Again, we have the SMD and other possibilities. SMDs are the difficult ones to solder, but smaller. But we are interested in through hole resistors. And we know our value. So let's find in the filter again our values. We need 82. So we can scroll down to 82. It should be here somewhere. 82. So actually they sell resistors of 80.6 ohm, but you see there's only 6 available. But 82, because of its a standard value in the E12 series, there's 100 that you can buy of them. So let's select 82 ohms and then show results. Then it's actually pretty simple. We just see what happens if we filter from cheap to expensive. Well, first there's always the ones that are not in stock. And then we have a through hole carbon film resistor, 82 ohms, 250 milliwatts. If we would provide more than 1/4 of a watt or 250 milliwatts of power, we need to find one that is higher rated for power, but it will almost never happen. When does this thing happen? When you have an extremely high voltage. Let's say you use 50 volts for one LED, then you need to strangle what is it, about 45 volts over the resistor, and since the power is the current times the voltage, you would end up with a lot of power actually that is been transmitted in heat by the resistor. But in our case we can just everything is good, so we selected from cheap to expensive, and what we see here that if well, we need to buy them in with tens, but it's only 2 cents, 2.3 cents per resistor. So if we buy 10 it would be 23 cents. You see, it's actually pretty cheap. So well, we found our resistor here. Actually that's all that there is to know about it. In a future video I will show you how to put LEDs in series or maybe even parallel. Depend if you want more than one LED, it's usually in parallel, but series also has its advantages. But well, I will do it in another video. So well, if you have any questions, maybe put it in the comments. I'm pretty new to YouTube. It's the first video I upload. But well, I hope you had something on it, and if you have questions, please ask them, or put it in the comments, or well, figure it out. So till next time, bye bye.